So today's session, I want to begin from here, and I want to begin the session from one very simple fact, which is very, very concerning. And that concern is the cutoffs are getting lower and lower every year. If you look into the last year trends of either CSIR net exams or a GATE exam or a JAM exam, one very common thing that you will find is that the cutoffs are going towards a higher side. Instead, they are going towards a lower side. And the reason to that is no one can actually give the reason, or no one can actually define in a very proper way that what is the exact reason. But let me tell you a very brief points here. Number one point that I want to mention is that few things that I find absent or missing as such in myself or also in the physics aspirants who are preparing for these common exams is number one, that is the respect for the field. Respect for the field. And I think if you are giving this examination, then I think you have some respect for the field. But in general, you have to appreciate the fact that every year almost 2 lakh people, and this is the data which is taken from the Government of India websites, from the sources, there are 2 lakh people who graduates, or you can say who passes the BSc or MSc physics. Either they pass through the BSc physics degree or they passes through the MSc physics degree. There are 2 lakh people every year from the different colleges, from the different universities throughout India. Out of these 2 lakh people, you are among one of them. Out of these 2 lakh people, 25,000 people gave CSIR net exam this year, and roughly 15,000 people give IIT JAM exam. So every year, around only 40,000 people are participating in some of the exams, because whoever gives the JAM, the same people give the Jest. So we cannot count Jest as a separate examination. So out of the 2 lakh people, only 40,000 people are interested in even giving the exam. Let's forget about, you can say, completely forget about who will qualify. Not even 50% of the people are actually going to the exam centers and giving the exams. Number one, I think, is a awareness problem, that people are not aware about the JAM exam. But I think everyone in this is aware about the GATE exams or NET exams. So what is the core reason that why people are itself not giving the exams? And the very core reason is that there is no respect for the field as such. There is a very common notion that physics is not good for earning money and physics is not good for jobs. So what are these 1,60,000 people every year do? And based on the friends that I have, based on the students that I have, I want to give you some of the areas in which these students are going, and then you can realize that where are we sitting in today's scenario. These people are going for PGT, TGT exams. They want to teach in the school level. The people are going for SSC examinations, government examination, SSC, clerical examinations, banking examinations. These people are going for, some of them are going for UPSC examinations. Some of them are doing the degrees from the same college from where they graduated. So for example, MSc pass student is doing the PhD from the same institution, and they are not giving the examinations. Some people are trying their luck in the stock market. They are now accepting the FNOs and trading as a full-time career. All of this basically shows either there is a lethargy of trying the new things, or either we want the results to be quick. That is the biggest concern at this time, that not even 50% of the students are actually going for this examination. And there is a very negative environment which has been spread out in this field, that physics is not good for jobs. However, from the last 1 or 2 years, I am trying my best to put many sessions on YouTube which are available. One of them is what are the jobs in physics. Number two, how you can take the MTech in semiconductor industry and get a job in the industries. How you can get a job in a coaching industry. So many sessions I have designed on YouTube, and to be very frank, physics has given me more money than any other career would have ever given me. But that is just my personal experience. But based on the overall experience, the reality is same in all the careers, that some we cannot have a economic equality throughout. If some people are trying for something, some of them will be successful, some of them will not be successful, but it does not mean that field is not giving you a equality or equal opportunities. Engineering has more opportunities than physics. Okay, let's agree, I agree to this point, but engineering has much more competition. There are 4 lakh people who give gate in engineering, there are only 20,000 people who give gate in physics. So if you look at the percentage selection rates, physics is still not that bad. And second of all, one very basic thing is that even if physics is bad, you did BSc or MSc in this, then why you weren't preparing with the BSc or MSc? When you were a part of a BSc or when you were the part of the MSc, students were not preparing for these exams, and many times they started serious preparation once their MSc was done, and now they are trying their luck for CSIR net exams in their drop years. So all of this is that respect for the field is missing. Number one thing, we have to accept an idea, and you will definitely accept this idea if you will go and watch my YouTube sessions, that physics can give you a very good job. Physics can give you a very good money. You want a government job, you can try for that. You want a private job, you can try for that. And physics, if you want you have some higher goals in your life, physics can also act as a plan B for that as well. So let's say you want to go for the something like, for example, you want to go for UPSC, then physics, many people are qualifying UPSC just based on the physics. Out of their maximum marks, they are getting the most of the marks in physics optionals. Right? Many people are going for research for 3 or 4 years, 5 years. You will ask these people, how is research? They will give you all kind of things. Okay, research is very bad. Research is very bad because you have to be 5 years in PhD. But after, when you ask these people after their PhDs, especially if you go to the ISERs and IASC and you ask the PhD students, they will be very frustrated. They will say, okay, no, 5 years is very, I'm in a lot of stress. But once they pass through the IASC and then you ask them, how is your life now? Then they will actually tell you where they are sitting at the different positions. And usually after they do the thesis defense, they are the happiest people. But before the thesis defense, they were one of the most stressful people. So that is obviously there. That is the nature of the field. No, you will not find many happy PhD students, but you will find many happy PhD alumni. And I can give you a long list of that. Okay. So one is that we have to respect the field first. If you don't respect this field, then don't try. Don't try for JAM, don't try for GATE, don't try for NET. Without the respect for the field, don't enter into this. Don't enter into the competitive exams, because you are not, I'm not just you, but we are not even working at the same level as the JE students. We are BSc, we are MSc students. We are at the age of 20 to 25 or even more than that. And on the other hand, we have JE and NEET aspirants whose average age is between 16 to 18. Every JE and NEET aspirant, even if it is an average, they are attending at least 7 hours of classes every day. They are going to the school and college or their coaching. They are at least doing 4 hours of average study every day. 12 hours of any average aspirant is going into their studies. And we also pass through that same phase. We also spend 10, 12, 13, 14 hours of our day unconsciously into the studies. We were not planning for that, but our lectures were so long and we have to sit through the college, we have to sit through the coachings, and we had to give 10 to 12 hours into the JE and NEET coaching. But on the other hand, if I talk about the MSc and BSc level, we are not reaching to the same level. We are not studying at the same level. Very few people can say, okay, they solve even 20 problems on average on a daily basis. 20 is a very less number, very less number. Because we are not either motivated to do that, or there is some problem. So first we have to motivate ourselves that, okay, this is the exam I want to qualify, and I have to put at least most of my day for this. And there is no tomorrow. That is the biggest. Okay, we will start from tomorrow. This is a new plan. This is a new plan. This is there is no tomorrow. Every day is a new day, and every day we have to prepare at a full level. Now, another problem, why you are not motivated is not your mistake. It is a mistake of a failures. And I have seen through it. This is my personal experience. The level of confidence in a JEE and NEET aspirant, or the level of confidence we had when we were in class 11th and 12th, was very high. We were talking a very large motivated things, that I will get into this and my salary will be that, and so many confident things we used to talk about, even though there was no basis of that. But now we are not even accepting a compliment from anyone. If someone say you are good in studies, we basically hesitate. Okay, oh no, I'm not good in studies, I'm an average. We are very low, we are getting low confident every single day. And I see that low confidence. Out of the 20 messages I received from the students, in 15 of them the message starts, sir, my name is ABC and I am an average student. So the introduction begins by tagging yourself as an average student, and sometimes people don't hesitate to call themselves below average student. And that is the biggest concern. Our confidence is dragging ourselves down and down, and every single attempt. First we tried for JEE and we failed, and then we tried for JAM, we failed. Now we are trying for NET and we are not getting a good luck in that. So our confidence is at a bottom level right now. Even you don't accept it, unconsciously your brain thinks that you cannot qualify exam. That is unconscious thoughts, and I know that unconscious thoughts. When I first time qualified IIT JAM, before that I never believed that I could actually get all India rank in any of the examination. And I don't think there is any aspirant who have not actually qualified the exam believes that, okay, this year they will qualify definitely. So confidence level is coming down. So because of that confidence, we are not that motivated to do the things and on a daily basis, because we don't think that we are going towards an achievement. We think that, okay, somehow we are doing a struggle, that this journey has become a struggle. So number two thing is we have to boost our confidence to some level. And there are only two ways to boost the confidence. Number one way is that you qualify some exam. Obviously, that is not in your hand entirely. Number two way is extreme hard work. Once you do hard work for 7 days, on the 8th day, you will have a confidence. Okay, I will just qualify any exam. Just a 7 day of or 10 days of very much pure hard work actually can boost your confidence levels, because then you will not blame yourself for not being disciplined. You will not blame yourself for not trying 100%, because once you make a plan and then you stick to that plan for 10 days, I think that big immediately gives you a confidence that, okay, you have at least overcome yourself. You have defeated your internal restrictions. And that is the main first thing, is that every aspirant has to focus on. First, I need to fulfill the goals which I have defined for myself. I will wake up at this time, I will study at this time, even if not exactly times, but at least I will study this many hours in a day, and I will cover this many questions every day. Number one is that you fulfill your dreams, and then you can think about qualifying the exam. So that will give you confidence. Without confidence, no teacher can help you. I cannot help you in any through any whatsoever course until unless you are not confident about yourself. Okay. And when you don't have a confidence, another problem which comes up is closing your eyes. And that is where I want to bring you. Closing your eyes and going to the superficial reality. Whenever I ask the students, why didn't you give the quiz which was floated in the course? My lectures were not prepared. I was not watched the. I haven't done the assignment. I have done the PYQs. That is why I haven't given the quiz. And then the quiz which was supposed to be given in 3 days is given in 10 days. And then why it happens? Because now we already have a low confidence and we don't want to fail anymore. We don't want to give the quiz, and we don't want to see the 30% score coming up, or 20% or 10% scores coming up. That is against what we want. So we stop giving the quizzes. We just keep watching the lectures one after one after one. If we are not watching the lectures, we are reading one book, then second book, then third book. One day we want to study Feynman lectures, another day we want to study Griffith's book, third day we want to watch the lectures of physics by, and fourth day any other coaching institution, fifth day someone else, and sixth day someone else. we just don't want to accept the reality that, okay, what is my skill in matrices? Okay, today I will self analyze myself about matrices. Do I know the topic matrices? Okay, let's give a quiz and let's identify that how much I score in matrices, how much good I am. If the actual matrix question comes in an exam in a little twisted way, can I solve this question or not? Do I have an ability or not? Let's accept that. And not giving the quizzes, closing your eyes about the reality, is basically one of the biggest problems that students waste their 6 months. You should know before the exam that tomorrow's exam, do you have a good chances or not? I'm not saying hopes. Consider yourself as a third person. When you start considering yourself as a third person, make yourself as a third person and analyze yourself as you will analyze someone else. Okay, if you have to analyze myself, how will you analyze? You will give me quizzes. Okay, do this quiz, and then you will look at the scores, and then you will see, and then you will ask me some questions, and then you will give me some assignments, and then you will check that if this person knows the topics or not. But we don't do this for ourselves, because we don't want to look into ourselves in a pure way. And this is the biggest mistake. I also made that many times. You might also be making at this. I'm not saying that you are definitely making this mistake, but it's a good chances that you are also making the same mistakes that I might have made in the past. But once you overcome this, then your growth begins. Then you know the boundaries that you have. I am good in matrices. I am not good in oscillations. I am good in, for example, when I give an interview for a teaching job, I always tell them I am very good in class 12th, but I am not good in optics. So I am not up to that level for optics, and they accept that. No problem. I know my boundaries. I know myself that where I have to score more and where I have to score less. So that is the one thing, that constant evaluation. You are preparing for a competitive exams. One is you learn the concepts. That is not the end of it. Then you need to know how to apply the concept. These two things can be taught. I can teach you these two things. Physics is also a skill. You have a skill also. Now you need a skill also. For example, what skill do you need? If I give you a new problem, can you solve it or not? And that is all about competitive exam. You need a skill of solving the new problems in less time. New problems, less time. New problems, less time. That is a skill you have. It was never about the knowledge. Competitive exams was never about the knowledge. It was never key, okay, how much knowledge do you have in physics, and how many concepts do you know? Maybe you know the concepts, but skill and knowledge is a two different things. And unfortunately, we are so much focused on the knowledge, we are forgetting about the skill. So now it is good time that we focus on the skill. And today's session will be about that, how you can develop these skills and how I developed those skills. My experience could be different, and you can just take a rough idea from this, rough tips from this, that how can I develop the skill? What is the skill here? The skill is solving the problems with limited knowledge. With limited knowledge in limited time. When you will reach at the level where any physics teacher is, for example, let's take my example, then you will start understanding that almost every subject of the physics is same. The same logics are used in quantum mechanics, same in electromagnetism, same in optics, and you need basically very limited knowledge. I remember very few of the formulas, but I can solve a jam paper, 70-80 marks I can get without any revision. And the reason being because you need very limited knowledge for physics, very limited formula. With this limited knowledge, if you know wave function, you can almost solve many problems in physics. There are very few problems in an exam which actually need a particular formulas, or which basically need particular knowledge. There are questions, but less of them. Only 20% of the such questions are there which need a formula for you to solve that. Otherwise, all the formulas can be easily derived. So how to solve problems with limited knowledge, not most of the knowledge, and in the limited. This is a skill. And how do you develop this? Number one, thing, you have to understand that you need to give time to the problems. And when you are solving the problems, let me be very, very clear with you. Let me be very, very clear. If there is an assignment which has 30 questions, and after the end of this assignment, you cannot find the links between the questions, that how the question number 1 was related to question number 6, how the question number 2 was related to question number 8. And if you think these were 30 independent questions, then you are wrong. In out of these 30 questions, what were the 5 formulas, or what were the 5 things you used? You should be able to summarize that. Physics is all about making the connections, that whatever problem you are solving, then how it is connected with that, how it is connected with this, how is it connected with that. Everything has a common connection. So developing the connection, and trust me, I have given hours and hours on just on problems. For example, when I was in BSc, I used to go to library and sit for many hours solving the random physics books, H.C. Verma, and then the book on university physics. And the university physics I did not like that much, but there was one more book which was very old print book, but there were problems were very nice. So you have to give some time. Don't count the time, don't calculate the times when you're solving the physics problems. Just do this for few days. Every day you just try to solve 30-40 problems. If you cannot, if you don't want to solve BSc MSc problems, just go for class 11 12. Open up the JEE mains book and solve JEE mains problems. They are also very good quality problems. You will see that how your brain functioning will change. And try to avoid looking at the solutions. We are looking at the solutions so much, so much, that we have a problem, and then we are going for the solution, and when we are seeing that, okay, this is how the problem is done. Oh yes, and now I understand. No, you do not understand. You don't understand a single thing. If you cannot start a problem in physics, then you don't know the problem. Understanding the steps of solutions is not actually doing the problems. Then you can just cancel that problem out. You don't understand this problem. You have just understood it for now. But if this problem I ask in any other way, in any random exam, you will not be able to solve this. I can guarantee you. If you have to look at the solution for the beginning the problem, to begin the problem with, then it is wrong. Maybe you begin the problem, but somewhere you are stuck at how to solve the differential equation, or how to solve this basically integral, or how to basically draw the graph of this function to get the final answer, or how you are making some mistakes, so your option is not matching with an actual option. If you are looking at the solution for any of such reason, then you are at the right track. But if you're looking at the solution to begin the problem with, what will be the first step, or what will be the formula to be used there, then it is wrong. Then you are at a wrong situation. What I usually do is, let's say I am solving the problem on electromagnetism, and let's say I have some circuit problem. And now I have a circuit problem, and now I'm thinking and thinking, I'm using all my brains. Okay, and then I suddenly realize that what I need is that potential at this point. If I know the potential at this point, I can calculate that and find this value what I actually need. And then I realize that, okay, in order to find potential here, I cannot use this. I evaluate all my tools. Can I use voltage division? No. Can I use KCL, KVL? No. Nothing can be. How can I find what will be the technique to use the voltage here, to find the voltage here? So that is what is going on in my mind. It is not going on in my mind, okay, how to start solving this problem. I know how I will get to this answer. I know the entire process in my mind. If somehow I am able to find the potential at this point, then I can do this, and then I can find the answer. But now, intermediate step, that how to find the potential at this some particular point, that I'm not able to get. Then I will go for the solution, and then some new tool I will learn, because then the solution will give me the new tool. Oh, you thought about the potential division, you thought about the KCL, KVL, but you didn't thought about nodal analysis. So this is what a nodal analysis is. So then you learn the nodal analysis. And then whenever the new problem will come, you will again, your brain will be stuck at the same point. Okay, now, okay, I need to find the potential here. Now your brain will give you three options. First, apply KCL, KVL. Second, apply voltage division. And third, apply nodal analysis. Then you can actually find out, then this question is teaching you something new. If you look at the question, you did not find any new concept, you did not understood any new formula, you did not understood any new way of doing the problem, then what does the solution taught you? No, nothing. It did not taught you anything. It is just another example problem. That's all. So don't stop wasting that time. Don't solve 40 questions, solve 10 questions, but make sure that you get the answer to that 10 questions by yourself. Read the theory 2-3 times. If you don't, do the solved examples, find the solved examples of the book, and then somehow try to get the solution of the 10 questions by yourself. If you cannot get the solution, start writing it down. Okay, specific heat has to be calculated. What are the ways that I want for specific heat? Okay, I can use equipartition theorem, I can use microcanonical assembly, whatever you know about specific heat, write all the formulas, all the methods, think about each and every, and this takes time. You will think that, oh, in this speed I will only do 2 questions in 1 hour. Yes, but those 2 questions are actually in the right direction. If you will look at the solutions and do 30 questions, that 1 hour is completely waste. Completely waste. Ideally, physics should not need much of the revision. If you are needing too much of revision, there is some problem in the preparation. If you are beginner, then it is okay, because if you are in BSc, then it will take some time to get used to those formulas. But if you are already given the exam 1-2 times and you need a lot of revision, that is a problem. Then you know the facts in a sequence. You don't know the facts in a problems. There is a difference. You go to the big coachings. I won't take the name. Any big coaching where you attend the lectures from day to night. You have a lot of notes, and then you will realize that you know the concepts in a sequence. Okay, de Broglie came, gave the wave nature, then wave function. Wave function has these properties. Then this is how you find operators. This is how you find average values, and everything you know is in a sequence. And then the question comes, and then you don't know that which part of the sequence I have to fit this question. Right, you are studying this. This is what happens when you study physics subject wise. Rather, you should always study the physics problem wise. I have this problem. How to find specific heat in physics? So one way is kinetic theory of gases in thermodynamics. One way is that if it is a specific heat of solids, then you go to the solid state physics. Then if it is a question from the statistical mechanics, for example, two energy system, then it is a question of a canonical ensemble. So in your mind, the concept is specific heat. You know the definition of specific heat, and you know the different areas in which the specific heat comes. And then the question will come to find specific heat. Your brain will exactly know the which box to put this question in, and then you will be able to solve the question in an exam. Otherwise, if you know the subject wise says, sequence wise says, then you can watch lectures of 20 institutions 20 times, you will not get a benefit. How to find magnetic moment? That's so. Let's say you read the new question today. I give you an assignment and you read the question magnetic. First, what is the definition of magnetic moment? What is the static material of this? Magnetic moment is this. Okay. How do I? Magnetic moment are calculated in electromagnetism also. Magnetic moment is calculated in atomic physics also. We find the angular momentum and then we find the relation of nu and L. Without looking at the notes, can you write one page of magnetic moment where you write the definition, where you give the formula which is used in electromagnetism, and where you give the formula which is used in atomic physics? So you see how quickly you are getting the connections, right? So that is what is need. Most of the peoples cannot give me the direct formula of magnetic moment, but then if I ask them, okay, start writing the definition of angular momentum in atomic physics, then you will make L vector, they will make nu vector, then they will say gyromagnetic ratio, then they will say L. So in that sequence, they know what is magnetic moment. But if I break that sequence and immediately ask what is a magnetic moment, that is a problem, and that is what exam is asking. Okay, how to find quantum numbers? Oh, okay. Is there any PYQs related to that? Yes, and this is the process. Okay, so that is what we have to learn, and the only way of learning that is not only to solve the problem. When you solve the problem by yourself, everything will get automatic. You don't have to do anything extra. Only thing that you have to do is make sure that you solve the problems yourself. You get to the answers yourself. Okay? And every subject has a peak. So this is where you are right now, and this is where you want to be, right? This is, you have to cross this barrier, and every subject, every topic has this barrier. In electromagnetism, electrostatics has this barrier, special topics of electrostatics has this barrier, dipole moment has this barrier, magnetism has this barrier, EM waves has this barrier, every topic has this barrier. And the way you cross this barrier for each, and you have to cross this barrier for each and every topic. And that is how you, what is this barrier exactly about? That when the 10 new questions are given, are you able to solve 6 questions or not? Initially, you will not be able to solve 6 questions. Whenever you pick a new topic and you decide that, okay, today I am picking the new topic, and by today night, I will be completing this barrier for this topic. No, sorry, this is not how physics works. You pick up the topic, you learn the basic facts first. EM waves, okay, this is EM waves, okay, this is the entire theory. Lectures are needed for that. So you watch the lectures, you get all the data in yourself, and then you go and sleep, and then you're watching Instagram, and then you're talking to your friends. Where is the analysis? Where is the analysis? You watch my lecture, and then after the lectures, you are not thinking about it. Then, and you are only thinking about the physics when you are in front of the books. But physics does not stop you to think. Please, when you are watching the EM waves, when you watch the lecture, maybe sometimes in peace, when you're listening to the music, in the background, think about the things you learned to. For example, if someone has to think about EM waves, what are all the things they can think? Okay, electric field is written as E naught. Okay, E naught is an amplitude, so something is vibrating. Then you can imagine what exactly should be vibrating inside. What is this thing which is inside sine? Why we are writing in terms of K vector, omega, T, minus, plus, all of these things that you learned in a class. Just give a quick recap in the background of your brain. And when you're solving the problems, you will not be able to solve all the problems. Then you have to open up your notes, open up your assignment, and do the mapping. Okay, question number 1 is from this. Question number 2 is from this. Usually what people do is, today they watch the videos, after the next week they get a time to solve the problems, and now they are solving the problems, and then they say, no, this isn't working out, I need new lectures. Oh, there is one Telegram group which gives the free lectures. So now they will again watch the entire EM wave from some other institution, another videos, and then again the problem solving is getting delayed and delayed and delayed. Okay, no, this question was not in Griffiths. Sir said Griffiths is a good book, but this question is not from Griffiths, this is from our assignments, right? So then you go for assignments. So don't stop shifting the sources one after one after one, and start analyzing the things. Once you watch the lectures, okay, be acceptful. Even if it is a Griffiths book, even if it is a physics bar lectures, even if it is a career endeavor lectures, or even if it is any lectures in the universe, they will cover 90% of the questions. 10% will be new questions. So now let's focus on 90% first. First question is from, let's say, intensity of the EM wave. So let's go to your notes. First, ask yourself what is intensity. First, you ask yourself. Don't just look at the notes directly. Okay, the question is on intensity. Forget about solving question. What is intensity? Okay. Where in my life I have defined intensity? Have I defined intensity in mechanics? No. In black body radiation, yes. In electromagnetism, yes. Where exactly in my life I have defined intensity? And what are all the formulas I know about intensity? And how to find intensity of an EM wave? And then you have the clear-cut idea in your mind. And then you look at the notes, and then notes will tell you, aha, this is how you find intensity of an EM wave. Don't stop there. Ask yourself why. And the answer to why is not derivation. That is the biggest harsh reality I learned in my life. In physics, the answer to why is not derivations. People do derivations. People start with derivations. I never start with derivations. I start with the result and then I go for a derivation, because once I know the result, then I have the question why. Why is this result is this? For example, the intensity is given by this 1 by nu naught E naught into B naught. This is the formula. Why? That is the question. Intensity of the EM waves is this. Now I have the question in mind that why is this intensity? Now if I go to the derivation, derivation will teach me how this is derived. But physically I have no sense of this, that why this is derivation. Why is this? From where it is coming? Then you try to look into the derivation and try to find out the meanings out of the mathematics. Ki, oh, okay, now I understand. It comes from the pointing vector. Okay, so and then you average the pointing vector, time averaging you do. Then you ask yourself why averaging. So then intensity is always an average quantity. Then you will understand intensity much more. Intensity is not a instantaneous thing. It is always an averaged quantity. And then you get this formula, and this formula will now never be out of your mind, because you know the main steps which reached this formula, which were used to reach this formula. And then you use this formula, and then comes the last step of the problem solving, which is solving the mathematics in a very, very nice way. And that is basically a practice thing, and all of us can do that. How fast you can do the mathematics, integrations, Dirac delta functions, Jacobians, how fast you can apply all of this. And with time you will learn that. That is okay. That is a skill that you will learn with problems. But the main idea is that if you're using the formulas blindly and then you're not thinking about them, then you're solving 30 problems is enough, as long as you're doing these 30 problems in a very nice way. If you do in a nice way, then no one can literally stop you from qualifying any examination. And always make sure you should know your boundaries. Okay, I'm going and you should know that, are you a good contender or not? Let's say I give you a new assignment, and in this new assignment, first 5 assignments you struggle a lot, and then 6th assignment you realize now you have started solving the problems. Okay, so then you will realize that okay, now you are becoming a good contender. Don't keep yourself in out of the vision. Keep a good vision on yourself. Quizzes, daily quizzes, that you realize that am I getting better or not. Okay, and always make sure that solve more and more problems. Please solve more and more problems. Just solve the problems for 6 months or 2 months, 3 months, 4 months. I cannot tell you that you will be the most confident person in physics. You can go abroad, you can get teaching job, you can get government job, you can get PhDs, you can get MTechs. All the path in India are open through the competitive exams. And there is a one common thing about competitive exams. How do you analyze? And once you do this for physics, you will understand you can do this for any subject. For example, I give you the book of a political science, you will be doing the same thing. Okay, constitution, why is happening like that? You will be doing the same thing with the Indian constitution as well. And listen to the interviews of the people who have qualified the government examinations or are good researchers. They are very analytical about the things. Okay, and you don't have to do anything special for that. You just have to be regular with the problem solving. Any day without problem solving is like you have missed your lunch or a dinner or a meal as such. And please be less and less interested about watching the lectures. so much. If you don't know the concept, then watching the lecture is the first step. But if you already know the concept, then do the quick revision and then come to the problems as soon as you can. Otherwise, you will be in a problem. Okay? So that is my ideas, and few of the sources that I want to mention is that if you want to qualify competitive exams, any competitive exam, the things are very simple. The steps are very simple. Identify the topics. So this thing I have done for yourself. You don't have to do this. I have done for you. Today I will give you the list of topics. That what are the total 80 topics in physics that you need to do for any exam. Okay? So identifying the topics I gave you. Number 2, book or lectures of a person who has either qualified the exam or is a standard book or is a good source. Don't do any random things. Like it should be good, like someone who knows what they are doing. So good book or good lectures, just that is important. And try to think about that. Learn it as a physics student, that you are learning a new concept, and then try to make a notes in a very good way. So for example, you watch the lecture, you can make the rough notes with the lectures. So let's say lecture is going on and you are making the rough notes, but these are the rough notes. Once the lecture is over, sit down, go for walk and something, and afterwards when you come back, then you ask yourself what was covered in the lecture. So you say, okay, intensity was covered. Okay, what is intensity? Then try to write what is intensity. Okay, what are the formulas of intensity? Write formulas of intensity. What were the kind of examples that were done in the lectures? Write those. That is how you make a notes. Question yourself and then write the answer on a notebook. Question yourself, write the answer on a notebook. So it is like an interview you are taking of yourself. So it is an interview between you and you. So Mr. R.N. Mehra, so you watched the lecture. So tell us something about this lecture. What is intensity? Okay, what is the units of intensity? Try to challenge yourself. Don't try to convince yourself that you know about this. Instead, try to challenge yourself. Okay. Okay. Tell us more. Or you can imagine yourself giving a lecture as Feynman technique. Feynman used to say that imagine you are giving a lecture to a unknown person who is imaginary person. Okay, ask every question. Intensity is a scalar or a vector? So these kind of questions you ask yourself, and then you make a notes, and then whatever data and whatever information is there in the notes should be in your notes as well. Whatever was covered in lecture should be in your notes. And 1 hour lecture needs at least 30 minutes of analysis. 1 hour of lecture means you have watched the movie. But when you analyze the movie, then you become a script writer. Then you become a director. You are not watching the movie for the entertainment. You are not a general audience. Don't become a general audience. If the 100 people in the theater goes to watch the movie, 99 of them are the general audience, but only one becomes a script writer by watching the movie. One become a good producer by watching the movie. One become a good actor by watching the movie. You have to be that 1% of this competitive exam. You have watched the lecture, but now you are watching the lecture for fun. Just general audience. Oh, okay. So this happened. Okay. And then end of the movie. No, 30-minute analysis is me. Oh, when the sad scene was there, they showed that sad scene on the bridge, and there was a night. So maybe night was darkness. So something like this kind of analysis should be there. Same thing with the lectures. 30 minutes of lecture analysis, and that 30 minutes you can do on the same day or on the next day. If you do on the next day, it will be a good revision of the previous day lecture. Okay? And this kind of analysis, you don't have to make a fixed time. Whenever you get time, do the analysis. If you're sitting in a bus going to the college, do the analysis. You are doing the lunch in your college, do the analysis. You are sleeping and you are not getting the sleep. Instead of doing overthinking, do the analysis. Right? So whenever you get 30 minutes of extra time, just do the analysis. Right? Many times when I go to the sleep, I wake up and then I pick up my notebook and start working, and I work 2 more hours. Because if I'm not sleepy, why to waste a time? Rather than I will just keep thinking about the things I learned. That is, 2 things are very important. Number 3rd is you need to cover up the PYQs in a very good way. Doing the PYQs means if I wake you up at 3 a.m. and I ask you, okay, oh, hello, I'm your teacher, and I saw that you watched the lecture on matrices today. So tell me what kind of PYQs have came in matrices in CSIR net. So you should quickly start saying, oh, one is that they say check the matrix is Hermitian or not. Okay, then they ask, okay, what are the eigenvalues and eigenvector properties? Then they ask the question on diagonalization and unitary transformation, sir. And then they also ask the question of one basic property, that formula you gave us. So this kind of prem, love for the PYQs you should have. You know everything about the PYQs, madly everything. ठीक है ना? PYQs is like, but what happens in just PYQs? What happens in net PYQ? And don't try to do over things. You are preparing for one examination and then basically you start doing for everything. No, pick up any one exam. Okay? One exam, two exams, at max 3 exams, and then try to know the PYQs of those exams very nicely. First time when I qualified IIT JAM, I was only preparing for IIT JAM. And I knew every single PYQ of IIT JAM, that what questions they have asked. And till today, if you give me any question, I can tell you if this question is related to IIT JAM or not. Till today. Okay? So you have to understand it. And then quiz or assignment. Quiz or assignment. This is to check yourself. You have to check, analyze if you know the concept or not. And if you don't know, after doing these 3 steps, if you cannot do this, then there is a problem. Then you don't have to wait till the exam to tell you that you will not qualify. Then you immediately know that you won't qualify. So let's say you gave the quiz in my course. Ask me, sir, I am scoring 30% marks in this quiz. Is it okay? Is it okay? Because not every quiz is made for 50%, 60%. Because in actual exams also, you don't have to score more than 50% to qualify any good exam. Right? So please understand that whatever you are scoring, you should know that. And then sometimes your score is 30%, but the actual score is more than 30%. How? Because some questions were not the part of the syllabus. Maybe they were put in that quiz. Some questions were not of the level of the exam you are preparing for. So you have to do a very good analysis. Out of 20 questions, how many questions were exactly of my level? And out of those, how many I could solve? If you could solve more than 80% of those questions, then you are at a good track. Don't look at the absolute scores. Look for the specific scores. Out of 20 questions, I analyzed the quiz, and out of 20 questions, I think 12 questions were of exactly of the same level as JAM. So I believe that out of those 12 questions, I solved 7 questions. So I'm on a good track. I still need to work on these 2-3 concepts which were not covered in the lectures, and they were in the quiz. So they are extra topics. So I need to work on that. This kind of analysis should be there for you in the quizzes. And then you will be realizing that you know it or not. If you don't know it, then you mark then you move to the next topic. But you have that in mind that, okay, for me, kinetic theory of gases, I only scored 30% marks. So this topic is done from my side, but not to a very good level. Okay? So what I will do is, in the next coming 7 days, I will solve the kinetic theory of gases, more problems, maybe daily 2-3 problems every day, maybe in the bus or maybe while going somewhere or something. Daily I will keep solving 2-3 more questions, and after 1 week I will again give a new quiz for kinetic theory of gases and then try to see again. Okay? So that is what happens. These 4 steps are required for preparation. So these are the 80 topics you have. I have maintained these topics according to each examination. 1 is very important, 2 is moderately important, 3 is not important, and 4th is there is no need to do this topic. And for example, first topic is kinetic theory of gases. So for net, it is important. For all of these exams, it is very important. You see, 0 means you don't have to do this for net, but it is important for JAM. Okay? So based on your exam, whatever you are preparing, this table will help you. So this is a table, and this contains 80 topics. Total 80 topics are there. 1 to 80. And once you do these 80 topics, your syllabus is complete. And anyone who wants to qualify this exam, you can first fix which exam you are preparing for. If you prepare any 50 topics out of this 80 to a very good level, your rank is secured. Pick any 50 topics out of this 80 and do them to the good level, you qualify the exam. Okay? And we are targeting using the Abhyas test series and revision. So this is one of the test series which includes revision as well. This is not just a test series, this is a revision as well. Okay? So 90 days are given for these 80 topics. So basically every day there is one topic. So out of this 90 days, for example, if you're a BSc student, then you only have to focus on the first 60 topics. So your syllabus will be done in 60 days. But if you're an MSc student, then you have to cover all the 80 topics. So it will roughly take 3 months of the period. What I'm going to do in this is that every day I'm going to take a live class at 7:30 p.m. One day in the week will be not means will be off. I will let you know which week, which day. Some days will be extra class and so on. Okay. So every day there will be a live class 7:30 to 9 p.m. This live class will discuss the revision, means what are the formulas you need, what is a basic definition of this topic, and what are the few of the PYQs you should know. Some PYQs I will also solve in this class. Okay, these are the kind of PYQs you should know. So there will be 80 to 100 live classes which will cover the topics revision. What are the formulas you need in kinetic theory of gas, what are the graphs, and so on. Okay. But if you want a complete details, you should watch my lectures. Okay. So if you join the course, you have the entire lectures. But in these live classes, I will be only focusing on the revision part. Okay. So topic-wise revision will happen. So this will give you idea. Okay, this is all the things I need to revise. And once your live class is done, then every day there is a DPP. And I will share you the DPP also. It's a very nice DPP. Every DPP is completely solved. And once you do this DPP, you don't have to do any extra PYQs. Because this DPP contains everything you need to know from the PYQs. So what are the important questions of NET, GATE, Jest, TIFR? All the PYQs are combined in this DPP. So you just have to solve this DPP. That's all. You don't have to solve in DPP and also PYQs. That will become too much. So just solve this DPP. You don't need any more practice. That's all. Then your PYQs are done. DPP is daily practice problems. DPP word means daily practice problems. Okay? So these DPPs I will share. You will be getting 80 DPPs. Total 80 DPPs you will be getting. For each topic, one DPP is there. Every DPP will contain 25 to 30 problems. So which basically means you are almost solving 2,000 to 2,500 questions in the next 3 months. Once you are done with these DPPs, you have 80 tests which are already been put up. So in Abhyas test series and revision, you have 80 topic-wise tests which are being put up. These are small tests, no, not very long. They are 40 minutes to 1 hour test. Means 40 minutes. Some tests are 40 minutes and some are 75 minutes. So this will actually tell you, do you know this topic or not? If you know this topic, then your scores will tell you that, okay. And then you will be able to identify that which topics are weak. Kinetic theory of gases are weak, thermodynamics is weak, oscillations are weak, which is weak topic for me. And I need to work on that. Okay? So 80 topics. And the very special thing about this is that after every test, you will get the video solution of the test. That, okay, this is how you should have solved the question. This is a short trick you can use. Maybe you can solve this question using the graph. So you will be able to evaluate yourself in much better way. Okay? So 3 steps: daily revision class, daily DPP, daily topic wise test. 80 topics we will be covering in the next 90 days. That is how the revision will happen. Now there are 2 ways to access this. First, 7 days will be free for everyone. For my course students, it is completely free, but I'm talking about the new students. So for first 7 days, you don't have to pay. You can just go to the website and you can access this course for 7 days for completely free. You can watch the 7 live classes. You can do the 7 DPPs. You can give the 7 tests and so on. After that, if you want to continue, you can buy the course. And If you want complete course, you can also buy our CSIR net course or JAM course, whatever exam you are preparing. If you buy our complete course, this thing is already included in that. If you buy the complete course, what is the benefit is that you will also get the complete video lectures also. For example, we are doing kinetic theory of gases. You don't know kinetic theory of gases, so revision class is not enough for you. You need complete lectures, so then you can watch the complete lectures. Okay? And then you can come and do the live class. Okay? So that is how it will work. But if you already know the syllabus, you only need the revision kind of thing, then you can just buy this Abhyas revision and test series course. You don't have to buy the full course in which everything is there. Okay? So you can go to our website and app and you can visit. And one announcement is there. You can use this code actually. Use the code Abhyas. You will get the 500 rupees off. Okay? And if you are buying the complete course, you can use the code NOW now. Okay? So use the code now if you're buying the full courses. And if you want to buy this course only, use the course Abhyas. In that you will get 500 rupees off, and entire thing you will get in only 3000 rupees. That's all. Fees is always maintained at a decent level, not very high, not very less. Okay? So this is what we have in idea. So I will share this PDF with you so that you have this 80 topic list in front of you, which you need to prepare. Now I want to take the doubts from you, and I hope that this session has given you some direction. Although I usually refrain myself from giving the direct tips, direct answers, but I have given you some, try to show you some path so that you can actually analyze. So more you analyze, more useful is this lecture is for. Okay? So now whatever doubts you have, please let me